Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Dear students of EASL third year, welcome to our first lecture in our course Distributed Information Systems. Actually, this course is consisting of three main chapters. The first chapter is HTTP protocol, the second chapter is Distributed Information Systems, and the third chapter is Distributed Object-Based Systems. Welcome. We can start our first chapter by the outline. First, we'll talk about our objectives of taking this chapter. The second point is about web application architecture. The third point is about taking a general idea about HTTP. Then we move to explaining URL. Then we will take different points belong to HTTP, which are features, operations, parameters, messages. Then finally, we will talk about Apache HTTP server, which we will take or we will use in our first practical work. Then HTTP specifications. Move to talk about our objective. Our main objective of taking the first chapter is to gain an understanding of HTTP protocol, the various modes of operation, and the different messages of HTTP. Here, I mean by messages the HTTP request and response between client and the server, and the elements used during HTTP communication between the browser and the server. So this is our main objective. Web application architecture. Many applications are running concurrently over the web, such as web browsing, surfing, email, file transfer, audio, video streaming, and so on. In order for proper communication over the network between the client or the browser and the server, these applications actually must or need to agree on a specific application level protocol. We can say protocol, or we can consider a protocol as a rule, such as HTTP, FTP, SMTP, PLP, and etc. All of these are different protocols used to organize the communication between different nodes or different browsers or different nodes over the network. Web application architecture, as we can see here in this figure, we can see a web browser and a web server communicate over HTTP or communicate using HTTP protocol, where the web browser needs to extract data from a storage system. HTTP overview. HTTP actually means Hypertext Transport Protocol. So it's an abbreviation of Hypertext Transport Protocol, which is a simple request response protocol layered on TCP/IP layer. Protocol for transfer. HTTP is a protocol used for transfer various data formats between server and client. The formats or data could be plain text, hypertext, images, videos, or sounds. This figure also demonstrates the messages held by the HTTP between client and the server. As we can see, the client or web browser sends a request message to the server, which in its turn responses or answers by sending a HTTP response message over TCP/IP to the client or the web browser. Uniform Resource Locator, URL. So, a URL is used uniquely to identify a resource over the web. It consists of 4 parts. The first part is a protocol, then a host name, then a port, finally a path and file name. A protocol, as I said before, it's an application level rule used by the client and server, for example, HTTP, FTP, and Telnet. A host name is the domain name, for example, www.test101.com or the IP address of the server. Port number is a TCP port number that the server is listening for incoming requests from the clients. And finally, the fourth part is path and file name, which is the name and location of the requested document or the requested resource, which can be a document of any type. For example, the URL http www.test101.com/docs/index.html. The communication protocol is HTTP. The host name is www.test101.com. The port number is not specified here, and it's 80 for HTTP. The path and file name for the resource is /docs/index.html. And the networking pause. So a TCP connection is created between client and server for each transaction and then terminated as soon as the transaction completes. Here in this slide, we've talked about the main features of HTTP. The first feature is stateless. HTTP protocol is stateless. What does stateless mean? Stateless actually means that each transaction treated independently, each new TCP connection for each transaction, and terminate the connection when transaction completed. These steps mean that the connection between the browser and the server is not continuous. The request and the response are not related. Each transaction is treated independently over a single connection between the browser and the server, and the connection is terminated when transaction is completed. Is connectionless. HTTP is connectionless, means that the browser initiates a request, and after a request is made, the client disconnects from the server and waits for a response. The server processes the request and reestablishes the connection with the client to send response back. So the first feature is stateless. The second feature is connectionless. The third feature is media independent. This means that any type of data can be sent by HTTP as long as both the client and the server know how to handle the data content or this file type. This can be allowed by sending another thing which is called MIME type. What is MIME type? MIME type actually stands for multi-purpose internet mail exchange. It's like a dictionary which holds it's like a dictionary which holds the different types of uh, files and their abbreviations or their extensions, more specifically their extensions. So, data content comes in all sorts and flavors. This immediately raises an issue how browsers can be equipped to handle the different file formats and ways to interpret embedded documents. Essentially, we need only two things: a way of specifying the type of an embedded document and a way of allowing a browser to handle data of a specific type. So each document has an associated MIME type. As I said, MIME stands for Multipurpose Internet Mail Exchange, and as its name suggests, was originally developed to provide information on the content of a message body that was sent as part of electronic mail. So, regardless this information, MIME is a dictionary exchanged between the client and the server to make them or to make handling the content or the file contents easily. So this dictionary MIME, we can consider it as a dictionary, holds the different files that could be exchanged between the browser and the server and their different types and the extension of each file. HTTP is stateless. Here is another explanation. HTTP is a connectionless, and this is a direct result that HTTP is a stateless a protocol. The server and client are aware of each other only during a current request. Afterwards, both of them forget about each other. Due to this nature of the protocol, neither the client nor the browser can retain information between different requests across the web page. So there is no connection or there is no relationship between the request and the response. Each one is handled as a separate connection or as a separate transaction. We move now to another point about HTTP, which is HTTP operation. Typically, there are three examples of HTTP operation. The first one is direct connection. Another example is intermediate systems, and the third example is a cache. We'll talk briefly about each example. Here, the first example about HTTP operation is called direct connection. As we can see here in this figure, relationship between a user agent, which is, for example, a browser or a client, and a server. The connection is simple or direct connection represented by a request and a response. And this is the simplest case in which a user agent or a client establishes a direct connection with the origin server. First, the client opens an end-to-end TCP connection between the client and the server. Then the client issues a request that consists of a URL and a MIME-like message. I have explained before MIME containing request parameters. We will see in the next slides the HTTP parameters and information about the client and perhaps some additional content information. So this operation is the simplest case, and it's called a direct connection. Direct connection between the client and the browser, represented by simple request from the client and simple response from the server. The server issues a MIME configuration file to map file extension to a media type. So that can ascertain the media type of the file by looking at its file extension. For example, file extension .htm or .html are associated with MIME media type text/html. Another example is file extension of .jpg or .jpeg are associated with image type JPEG. When a file is returned to the client, the server has to put up a content type response header to inform the client the media type of data. So this dictionary should be exchanged between the client and the server. When the server receives the request, it attempts or it tries to complete the request and returns an HTTP response containing status information, a success error code, and a MIME-like message containing information about the server, information about the response itself, and possible body content. In the next chapters or in the next slides, we'll talk also about HTTP messages. So HTTP parameters and HTTP messages. All these points will be discussed in the next slides. The second example of HTTP operation is the intermediate systems. Intermediate systems, as we can see here in this figure, are adjacent systems. Here A, B, and C. A, B, and C between the client and the browser. In this scenario, or in the scenario of intermediate systems, there are one or more adjacent systems with TCP connections between the client and the server. Each intermediate system acts as a relay or as a connection, so that a request that is initiated by the client is moved and transferred through the intermediate system to the server, and the response from the server is moved back to the client and sent back to the client. So there are three forms of intermediate adjacent systems defined in the HTTP specification. We have a proxy, a gateway, and a tunnel. Proxy, gateway, and tunnel. What are they? The answer is, we start by the first adjacent system, which is a proxy. A proxy acts on behalf of other clients and presents requests from other clients to a server. The proxy acts as a server in interacting with a client and as a client in interacting with a server. Here in this figure, we can conclude that a proxy is a system which can act as sometimes as a client and sometimes as a server based on the needs of the connection. So the proxy is an intermediate system between the client and the server. Its role is to act sometimes as a client and sometimes as a server. Another intermediate system is called gateway. Gateway is a server that appears to the client as if it were an origin server. It acts on behalf of other servers that may not be able to communicate directly with a client for any reason related to the network. So we conclude that gateway here plays the role of a server. The server here cannot handle the requests of the browser for several reasons. So the gateway will take this role in handling, or will take the role of handling the requests of the client and deal with the client as if it were a server. The third intermediate system, called tunnel. The tunnel performs no operations on HTTP requests and responses. It's a relay point between two TCP connections. So it is a connection. So it is a point of connecting. It's a point of connecting. Tunnels are used when there must be an intermediary between the client and the server. For example, a firewall in which a client or server external to a protected network can establish an authenticated connection and then maintain the connection for purpose of HTTP transactions. So we take the first intermediate system, which is a proxy. We said that a proxy plays two different roles, sometimes the role of a client and sometimes the role of a server. The second intermediate system is the gateway. Gateway plays the role of a server to deal the requests of the client. The third intermediate system is a tunnel. We say that tunnels perform no operations on HTTP requests and responses, either from clients or from servers. So this is the general idea about all this stuff. We move HTTP parameters. A list of the important HTTP protocol parameters and their syntax in the way they are used in the communication. Here I mean the parameters. Parameters actually are sent in the request and responses messages. So first we'll talk about them, then we move to talk about the messages. The first parameter included in the message is HTTP version. The version of an HTTP message is indicated by an HTTP version field in the first line. For example, we have HTTP /1.0 or HTTP /1.1. Another parameter is Uniform Resource Identifier, URI. It's simply formatted, case-sensitive, string containing name, location, etc. to identify a resource, for example, a website or a web service, etc. And this is an example parameter. Another parameter is date-time formats. All HTTP date-time stamps must be presented in Greenwich Mean Time, GMT, without exception. We have here different representations of date-time stamps. For example, in the first example, the first three letters of the date, sun, then the date, then the time. The other example, we mention all the whole letters of the day are mentioned, the letters I mentioned, then the date, then the time. The third example is written in a different way. Another parameter is called character set. Character set. You use character set to specify the character sets that the client prefers. For example, ASCII code, etc. Multiple character sets can be listed separated by comma. If a value is not specified, the default is the ASCII code. We have different examples of character sets using as parameters in HTTP messages. We move to different parameter, which is content encodings. A content encoding values indicate an encoding algorithm used to compress or to transform the content without losing its identity. So we can find different algorithms that can be used before passing the message over the network. The content codings are primarily used to allow a document to be compressed or otherwise usefully transformed without losing the identity. We have different accepted encoding algorithms here. For example, deflate, compress, etc. Another parameter called media type. Media types, HTTP uses Internet media types in the content type and accepts header fields in order to provide open and extensible data typing and type negotiation. All the media type values are registered with the Internet Assigned Number Authority, IANA. So, media types like mine type includes the main type accepted to be transferred through the network over HTTP protocol. Language tags. HTTP uses language tags within the accept language and content language fields. A language tag is composed of one or more parts, a primary language tag, and a possibly empty series of sub tags. We have here like English, Big Latin. All these are tags for the accepted languages.